When evaluating a limit, the first thing that one should try to do is plug in the value that the variable is approaching. In this problem, the variable x is approaching 0, so we should try plugging 0 in for x. And when we do so, we obtain the following result. A lot of students want to say that infinity minus infinity is equal to 0, but in fact that's not the case. It's actually an indeterminate form. So the key to solving this type of problem is to rewrite this difference as a quotient. And to do that in this problem, we're going to have some knowledge of trigonometric functions. We must remember that the cosecant of x can be rewritten as 1 over sine of x, and that the cotangent of x can be rewritten as cosine of x over sine of x. So let's go ahead and rewrite that as follows. Now, this difference has a common denominator, so we can actually combine it into a single expression. Now, if we try plugging 0 in for x in this expression, we're going to obtain an indeterminate form of a different type. We're going to have 1 minus cosine of 0 over sine of 0. The cosine of 0 is 1, and 1 minus 1 is 0, so we're left with 0 over 0. The sine of 0 is also 0. And this is an indeterminate form of a different type, but it's this form that we can apply L'Hopital's rule to. And that's exactly what we're going to do in order to proceed. Now recall that L'Hopital's rule says that to evaluate a limit that is an indeterminate form of 0 divided by 0, we can take the derivative of the numerator and the derivative of the denominator, rewrite the limit, and evaluate it. So let's go ahead and try that. So we'll write LH here to represent L'Hopital's rule. We have the limit as x approaches 0. We're going to take the derivative of the numerator. We have a constant minus cosine of x. Now, the derivative of cosine of x is negative sine of x. And then we're also going to take the derivative of the denominator. And the derivative of sine of x is cosine of x. So if we clean this up, we have the limit as x approaches 0 of sine of x divided by cosine of x. And recall that sine of x divided by cosine of x can be rewritten as tangent of x. So in fact, we can rewrite this one more time as the limit as x approaches 0 of tangent x. Now, if we go ahead and plug 0 in for x, we have the tangent of 0. And of course, the tangent of 0 is 0. And that is indeed the correct answer.